Hello everyone. In this video, I'm explaining how to find number of elements of order k in dihedral group. Dihedral group is denoted as Dn. You know that Dn has 2n elements. Number of elements in Dn is 2n. D3 has 6 elements, D4 has 8 elements and so on. We want to find out number of elements of order k. Therefore, there are two cases. The first one is k equal to 2 and the second case is k not equal to 2. K equal to 2 means you have to find number of elements of order 2 in dihedral group of Dn. So, when k equal to 2, so number of elements of order 2 in Dn is given by n if n is odd and n plus 1 if n is even. This is the formula. You have to check the value of n, dn. If it is d3, d4, d5 like that. If it is d3, then n equal to 3. 3 is odd. There are 3 elements of order 2 in d3. If it is d4, 4, n equal to 4. 4 is even. Therefore, 4 plus 1, 5. Therefore, there are 5 elements of order 2 in d4 and so on. Now, if k not equal to 2, then number of elements of order k in Dn is equal to phi of k provided k divides n. Provided k divides n. Not for all possible k. If k divides n, then only you have elements of order k, and if you want to find number of elements of order k, then it is phi of k. Phi of k is the Euler's phi function. This is the formula. Let us take example. Let us consider D3, dihedral group of order 6. There are 6 elements. D3 it is. So, 3 into 2, 6 elements are there in D3. Now, you have to find out here n equal to 3. N equal to 3. Therefore, two possibilities, k equal to 2 and k not equal to 2. So, number of elements of order 2 is equal to, here n value is 3, it is odd, therefore as per the formula it is equal to 3. There are 3 elements of order 2. Now k not equal to 2 and k divides n. N is 3 here, k divides 3. What are the divisors of k? K equal to 1 and k equal to 3. These are the divisors of k. Therefore, you have to find out number of elements of order 3 now. Of order 3. These are the possible orders. Possible order of any element in D3 is either it is 2, either it is 1 or 3. No other possibilities. And you should remember one thing in Dn, maximum possible order of any element is equal to n. No other possibility. Though it has 2n elements, you can never have any element of order 6 here. Maximum possible order is n. That is here in this case it is 3. So, number of elements of order 3 is phi of 3. So, phi of 3, how to find out? Phi of p is equal to p minus 1 if p is prime. Now, 3 is prime, therefore, it is 3 minus 1. This is equal to 2. I have already uploaded a video on Euler's totient function, how to calculate phi of n for any positive integer. If you don't know how to calculate phi of n, then watch that video and learn how to do that. Then apply the same procedure here. Now, p is prime means phi of p is always p minus 1 directly. 3 is prime, 3 minus 1, 2. Therefore, there are 2 elements of order 3. Order 1, you already know, every group has only one element of order 1, that is identity element. So, number of elements of order 1, that is always equal to 1 for any group. So, totally how many elements D3 has? 6. Therefore, there are 3 elements of order 2, 2 elements of order 3 and 1 element of order 1. Totally how many? 3 plus 2, 5 plus 1, 6. Done. So, maximum possible order in Dn for any element is n. Though it has 2n elements, maximum possible order is n. So, this is the formula. One more case you consider. You consider D4 now. D4. Okay, D4 has how many elements? 2 into 4. Totally there are 8 elements. But maximum possible order of any element, maximum possible order equal to n, that is 4. So here in this case n equal to 4. Okay. Now you have to find out number of elements of order 2. Okay, there always exist elements of order 2 in any dihedral groups, because it is having 2n elements. Order of any element divides order of group, so 2 always divides 2n, therefore this is compulsory. Okay, number of elements of order 2, which is equal to, what is value of n? N equal to 4. This is even now. So as per your formula, when n is even, n plus 1 elements of order 2 would be there in that group. So it is n plus 1. 4 plus 1 means 5 elements are there. Okay. Now next case is k not equal to 2 and provided k divides n. So what is n now? K divides 4. So what are the divisors of 4? 1, 2, 4. 2 already over here. So you are remained with 1 and 4. So divisors of 4 now 1 and 4 here. A number of elements of order 1 is equal to 1, because there always exists only one element of order 1, that is identity element. Now you have to find out number of elements of order 4 in D4, which is equal to, as per your formula, phi of 4. Okay, that is phi of 4. How to find out phi of 4? Which is phi of 2 square. 4 can be written as 2 square. So it is equal to 4 into 1 by 2. So as per your formula, phi of n equal to n into 1 minus 1 by p power P1, 1 minus 1 by P2, so on up to 1 minus 1 by Pk. That means if n is prime, then phi of n is P minus 1. So phi of n equal to n minus 1 if n is prime. Okay. If n is not prime, then it is composite. If it is composite, you know that every composite number is a product of primes here, alpha p power k alpha k. Then in that case phi of n is calculated as n into 1 minus 1 by p1, 1 minus 1 by p2, and so on. Detailed video is uploaded, you watch that video. Now I want to calculate phi of 4. So 4 into 1 minus 1 by 2 here, this is equal to 2 square is 4 into 1 minus 1 by 2, which gives you 1 by 2. So cancels, this is equal to 2. Therefore there are 2 elements of order 4 in D4. So totally it has how many elements? 8 elements. Let us count. 5 plus 1 6 plus 2 8. So totally there are 8 elements. One is of order 2, one is of order 1, one is of order 4. That is categories. Order 5, order 6, that are all not possible, because order of any element should divide the order of group, one thing, and if k is not equal to 2, then k should divide n. And one more thing to remember is maximum possible order of any element in Dn is n. It cannot exceed n. Similarly, you can check for D5, number of elements of order 1 equal to 1, number of elements of order 2, which is always equal to, here 5 is odd, therefore 5, n if n is odd, n plus 1 if n is even. Number of elements of order, other possible order, 1, 2 always there. Okay, other possible orders you have to find out only if k divides n. So k divides, here n is 5. What are possibilities? 1 and 5. So number of elements of order 5 is phi of 5, which is 5 is prime. So 5 minus 1, 4. 5 plus 4, 9 plus 1. Totally there are 10 elements. One element is of order 1, 5 elements are of order 2, and 4 elements of order 5. Done. I hope you understood. Thank you for watching.